I am Dr. Vetria Byrd with the Polytechnic Institute at Purdue University. Thank you for your interest in the usability of data visualization activity worksheets in the context of a critical data visualization workshop, findings from a usability survey. This work is sponsored by the National Science Foundation. In this work, a data visualization activity worksheet method was designed to introduce data visualization to participants of a workshop on critical and ethical approaches to data visualization. The 5-day workshop was held in summer 2019 at Purdue University. One of the workshop goals was to introduce the complex data visualization process to novice visualizers in a short period of time. Towards achieving this goal, data visualization activity worksheets were utilized to scaffold the data visualization process. The workshop attracted a cross-section of 25 participants from 16 universities, which helped to form interdisciplinary teams during the workshop. The workshop was structured to allow for a lecture format in the mornings and hands-on activities in the afternoons to apply and reinforce concepts learned in the first part of the day. This table shows the lecture topics and activities for each day. The 7 stages of visualizing data was introduced incrementally over the 5-day workshop, culminating in team presentations where participants could showcase what they have learned about the data visualization process. Microsoft Excel was the tool used for pre-processing of data, and Tableau was the tool used for visualizing the data. Visualizing data is a non-trivial, multi-stage, dynamic, non-linear process. For this work, the 7-stage process, illustrated and described by Ben Fry, shown here, is adopted. There are numerous models and approaches that describe the visualization process. This model was selected for its simplicity and ease of understanding the inherent iterative structure of the process. As you can see in this figure, output from one stage serves as input to other stages, and it can be a bit overwhelming for the novice visualizer. The data visualization activity worksheet method was introduced to help mitigate the intricate process of visualizing data. The aim of the data visualization activity worksheets is to give participants a strong foundation in visualization principles, design, and ethics so that they can continue to use these skills after the workshop in their academic and professional practices. Each worksheet represents a stage in the data visualization process. Output from one worksheet serves as input to the next worksheet. In the interest of time, only the first 3 stages of the process and the worksheets developed to explore them are provided in this work. The iterative nature of the process is represented by visual indicators of other stages in the process that are directly impacted by the outcomes from that stage. Although presented in a linear fashion, keep in mind during the visualization process, you can be in any stage of the process at any given time. We begin with the acquire stage. The acquisition step involves obtaining data. Like many of the other steps, this can be either extremely complicated or it can be very simple. The goal of the Acquire worksheet is to identify appropriate data sources, identify data types, variables, and list assumptions about the data. The objective of the worksheet is to guide students through steps to help them to identify and acquire data from the appropriate data sources. Upon completing this worksheet, students should have data for the current visualization challenge readily available. Also notice the acquire stage serves as input to the parse stage, but is also impacted by other stages further into the process. For example, the represent stage. In the parse stage, each piece of data needs to be converted to a useful format. The goal of the parse activity worksheet is to understand the structure of the data. The objective of the worksheet is to change data into a format that tags each part of the data with its intended use. The outcomes for this worksheet will be for every element of the data to be broken into its individual parts. The assumptions about the data are also articulated. Output from the parse stage serves as input to the filter stage, as seen in the lower part of this slide. The third worksheet is the mind activity worksheet. The mind stage involves mathematics, statistics, data wrangling, pre-processing, and performing statistical calculations. Most of the time, this step will be far more complicated than a pair of simple math operations. The goal of the mind stage is to identify patterns, extreme and subtle features about the data. The objective of the worksheet is to facilitate the mining stage by identifying basic descriptors for the data, categorizing the data according to its specifications from the parse worksheet, and identifying those questions that define the research underway. Notice the mind stage is directly impacted by multiple stages and directly impacts the next stage in the visualization process. Data collection consisted of the design activity worksheets and post-worksheet usability survey responses. Only outcomes from the post-survey responses are presented in this work. The usability survey consisted of 11 questions. Column 2 shows the areas of assessment ranged from the likelihood of use to the need for prior knowledge before using the method. Participants were asked to indicate their level of agreement to statements on the usability survey using a 5-point Likert scale. Response options included strongly disagree, disagree, neutral, agree, and strongly agree. Basic statistical indicators, such as the mean, median, and mode, were calculated to determine significance. Only outcomes from the post-usability survey responses are calculated in this work. A total of 23 participants completed the usability survey. Responses were categorized into the following subscales: participants' perception of the usability of the method, participants' ability to learn to use the method, and frequency of use when applying the data visualization process. Participants' perception of the usability of the method was captured in statements 2, 3, 9, and 10 on the post-worksheet survey. Mean values for statements 2, 3, 9, and 10 ranged from 3.0 for statement 2 to 3.6 for statement 10, indicating, on average, students' responses were neutral, according to the Likert scale. For this study, a neutral value of 3.5 or higher is considered a favorable response, leaning more towards agree. A neutral value between 3 and 3.4 is considered leaning more towards disagree. Participants' perception of the learnability of the method was captured in statements 4, 6, 7, and 8 on the post-worksheet survey. Mean value for the learnability scale is 3.6, indicating, on average, participants found the method to be easy to use and learn. There was a mode value of 4, indicating most of the responses tended to be more positive, which corresponds to agree on the Likert scale. Statement 6 has the lowest mean value of 2.0, which corresponds to disagree on the Likert scale. On average, students disagreed with statement 6 and did not think there was too much inconsistency in the activity worksheet method. Statement 4 has a mean value of 2.3, which also corresponds to disagree on the Likert scale. This mean value indicates on average students disagreed with statement 4 and did not think technical support would be needed to use the activity worksheet method. Statement 7 has a mean value of 3.6. Since this value is greater than 3.5, we interpret the mean to be leaning more towards a value of 4, which corresponds to agree on the Likert scale. We conclude, on average, students agree that most people would learn to use the worksheets method very quickly. Statement 8 has a mean value of 3.0, which is rounded up, which corresponds to a neutral value on the Likert scale. We interpret this score to be leaning towards disagree. We conclude, on average, students disagree with statement 8 and did not find the worksheet method to be very cumbersome to use. Participants' perception of the frequency of use of the method was captured in statements 1, 5, and 11 on the post-worksheet survey. The mean value for statement 1 is 3.6, which corresponds to a neutral response. However, the mean value is above the study's threshold of 3.5 or higher and is leaning more towards agree. We conclude, on average, students agree they would like to use the data visualization activity worksheet method frequently when applying the data visualization process. The calculated mean for statement 5 responses is 3.8, which corresponds to neutral on the Likert scale, but is above the study's threshold of 3.5 or higher for favorable responses. We consider this value to be leaning more towards a value of 4, which corresponds to agree on the Likert scale, which suggests, on average, students found the various parts of the method were well integrated. Statement 11 had the lowest mean value of 2.4, corresponding to disagree on the Likert scale. The mean suggests, on average, that students disagreed with statement 11 and did not feel additional knowledge is needed to get started using the worksheet method. Although encouraged by the previous results, we acknowledge there are limitations. A large number of new material is covered in a short period of time. A 16-week data visualization course was scaled down into 1 week. Participants were from various disciplines and academic backgrounds and preparation. Participants arrived with little knowledge of the data visualization process. Participants were asked to quickly get to know and work with other teams or their team members while also navigating potential project tasks. Overall, response to the novel data visualization activity worksheet approach was positive. Data visualization, much like the engineering process, is an intricate process that requires critical thinking and problem solving. A method that facilitates the practice of transferable skills, such as the data visualization process, will benefit students beyond the classroom into research practices and daily tasks. Future work in terms of implementing data visualization activity worksheet methods will include iterative refinement of the process. We will fully integrate team science and data visualization ethics into the data visualization activity worksheets. We will also develop additional strategies for capturing impact of the critical and ethical aspects of the data visualization process. This concludes the presentation.